In this video, we're going to use logarithmic differentiation to find the derivative. Okay, so for step one, we're going to apply logarithm to both sides. Apply ln to both sides, so we get ln of y equals ln x cotangent x. Now, why would we do that? Because we want to use the properties of logarithms that will make things easier. Now, in another video, I wrote those down, and I'm going to copy and paste them so I don't have to write them again. All right. So we have these properties of logarithms. And one of the, we have ln of a times b is ln of a plus ln b. ln of a divided by b is ln a minus ln b. ln a to a power, say t, is t ln a. That's the first one I'm going to use right here. I have x raised to the cotangent x power. I'm going to bring that to the front here. So now I have, so that step would be maybe called expand. I'm going to expand. So I'll have L of ln y equals cotangent x times ln x. So because I brought the cotangent x to the front. Okay. Now, the next step is we're going to differentiate. On the left-hand side, we see ln y, and I'm differentiating with respect to x. So what I do is I do something that we saw in implicit differentiation section. I'm going to find the derivative of ln y, which is 1 over y. That's the derivative of ln y with respect to y. But then I multiply by the derivative of y with respect to x, dy dx. That's how we find the derivative of ln y with respect to x. Then on the right-hand side, I use the product rule. Well, why? There's a product there, that's why. So there's a product there, so I'll use the product rule. And how I do that? Well, I can first just sort of write down what I plan to do. I'll take the derivative of cotangent, then I'll take the derivative of ln. Then I'll add cotangent times the derivative of ln x. Sort of just barely fit that in there, but okay. All right. So then let's go ahead and actually fill in the derivative of cotangent x and ln x. So I have 1 over y prime. It's really important to write both sides of this. Now, there's a formula for derivative of cotangent x. I recommend you memorize it. The derivative of cotangent x is negative cosecant squared x. For the trig functions, all the ones that have co, when you take the derivative, got to have a minus in front. Then I'll copy down ln x. Next comes cotangent x. Just copy that down. Now the derivative of ln x is 1 over x. All right, so moving along here, I'm going to multiply by y, and I get y prime is equal to y, all this stuff, negative cosecant squared x times ln x, and over here, cotangent x plus cotangent x divided by x. Then I will substitute back for y. Well, what do I mean by that? In our original, above here, we see y is equal to x cotangent x. So I'm going to fill that back in there. X raised to the cotangent x power. We see that was our original problem of what y equals. And that really finishes everything off on that. so it's a long problem, but the idea is you take this larger problem and you break it into smaller pieces, and each piece is easier. It's a long process to learn, but the individual pieces are sort of short. And of course, it looks longer because I put in little notes here and talked a bit. Okay. Now let's do another problem where we use logarithmic differentiation. On this problem, notice what we have. We have y equals a function of x raised to a power, which is a function of x. You can't use the power rule or anything like that. I think you have to use this. Maybe there's something else, but I don't know about another way. But this is a function of x raised to a function of x. Let's look at another problem. This one we can use logarithmic differentiation. And what's going on here is it's just simply that we have a function that has some products and it has some powers, some exponents. And if I use the properties of logarithm, I can make this easier to differentiate. Well, how can I use the properties? Well, I have to first apply logarithm. There's no logarithm here. So I bring that into the whole thing. Apply ln on both sides. By the way, I'm also writing the cube root of x squared minus 4 as x squared minus 4 to the 1/3. Then what I'll do is I will expand, and when I expand, I need to use properties of logarithms. Well, the first thing I see is that I have logarithm of a difference. So I can break that up into two logarithms. Sorry. I have logarithm of a fraction, a logarithm of a quotient. So I can break that up into two logarithms where I have a difference. So a fraction inside the logarithm becomes a difference on the outside. So that's what I'm going to do here. All right, so I just broke that quotient up into two logarithms and have a difference there. Then I'm going to expand by bringing the 1/3 to the front. I think if you get more, used to this, you can do this. You can combine these two steps. Now, in fact, you can even go further and you could say, well, what about x squared minus 4? That factors, and then you could break that up. Sort of didn't even think of that, but maybe, I think I won't do that. But you could write x squared minus 4 as a product, x minus 2 times x plus 2, and break that up into 2. That's sort of interesting, but maybe I won't do that in this, because I don't think it's going to make it that much simpler to work with. Okay, the next thing is I will differentiate. Now, for this logarithmic differentiation, the left-hand side always has the same trick there, is that it's the derivative with respect to x of ln y, so I get 1 over y prime. And then for ln x plus 11, that's 1 over x plus 11 times the derivative of x plus 11, but that's just 1. I'll just put that there. Usually I wouldn't do that, but I just think I want to point out that the derivative of the inside function is 1. Minus 1/3. Now for ln, I have the derivative being 1 over x squared minus 4, and I take the derivative of what's inside. The derivative of x squared minus 4 is 2x. So getting going on this, we're really moving along. Multiply by y. I'll have y prime equals y times all this stuff. 1 over x plus 11 minus 2x, 3x squared minus 4. And then, well, what's y? I need to put back what y is. So substitute back for y is maybe what I'll write. Substitute back, I guess that's the expression that I'll use. Okay, substitute back for y. What I just mean there is I'm going to replace y by what it says it is originally. It's x plus 11 divided by the cube root of x squared minus 4. It's a lot, but let's just go for it. Okay. So what happened is, what did we do? We had this long problem, but I avoided using the quotient rule. I avoided using just a lot of the stuff that would be involved if I were going to just take the derivative of x plus 11 divided by cube root of x squared minus 4. If I just did it directly without using logarithmic differentiation, it would have involved a lot of more things. Well, maybe. Anyway, this is one way to do it. You apply logarithm, expand, take the derivative, and get the answer. I'm not sure if I convince everyone that this is easier, but this is the technique. Okay, so that finishes the video.